Hello everyone, welcome to a new video. In this video, we will talk about the determinacy, indeterminacy of different structures, that is beam, truss and frame. So let's go to the video. At first, we need to understand what is determinate and what is indeterminate structure. We all know that we have three equilibrium equations in mechanics. That is, if you write down the equations here, that will be summation fx is equal to 0, summation fy is equal to 0, and summation moment is equal to 0. We have three equilibrium equations in our hand. So whenever the unknown reaction forces are less or equal than the three equilibrium equations, then we can say that the structure is a determinate structure. And if the reaction forces are greater than the equilibrium equations, then we can say that the structure is an indeterminate structure. So if we look at the definition, if the number of unknown reaction component is less than or equal to the number of available static equilibrium equations, the structure is said to be a determinate structure. And if the number of unknown reaction exceeds the number of static equilibrium equations, then the structure is said to be indeterminate structure. Now we have to understand what is the unknown reaction here. Whenever we are considering a beam, we are trying to solve or analyze a beam. There is a point load acting here, and we have a total number of three unknown reactions here. That is R of A. If this is a point, this is B point. H of A and R of B. So these are the unknown reactions. Okay, so whenever we are analyzing the beam, the support reaction will be the unknown reaction here. Okay, so what is degree of indeterminacy? Degree of indeterminacy is the difference between the number of unknown reaction and the static equilibrium equations. So we can write down the degree of indeterminacy as R minus E. Okay, what is the relation of stability and indeterminacy? So two different things. One is stability, one is determinacy. Sometimes they are quite similar, sometimes they are not. Suppose we have a beam. There are two roller support at the two end of the beam, and load is acting here. So we have two unknown reaction here, that is R of A and R of B. This is A point, this is B point. So the value of R will be 2 and the value of E, we all know that, is 3. So here R is less than to E. So we can say that this is a determinate structure. But where is the problem? The problem is that if we pressure on the beam, or if we keep pressure from the sides, the beam will move. Okay, the beam will move. It is not a stable beam. So this is the difference between stability and determinacy. Stability means it is stable. Whenever we are acting some load on it, it is always stable. So this is stability. So there are two kinds of stability, that is external and internal stability. So if you look at the external stability, then we can say that if R is greater or equal to E, the structure is stable. As R is less than E, the structure is not stable. And if R less than E, the structure is unstable. So this is how we will calculate the stability of a structure. Okay. And if R, as already we know that if R is lesser or equal to E, the structure is statically determinate. So whenever a structure is determinate of DOI value is equal to 0, the structure is stable and determinate. But if there is a negative DOI value, then the structure is unstable. Okay. So what is internal stability? If DOI is equal to 0, the structure is stable and statically determinate. Okay. If DOI is greater than to 0, the structure is stable and statically indeterminate. And if DOI is less than 0, the structure is totally unstable. Okay. So we will do some further analysis here. So now we will calculate the value of degree of indeterminacy of beams. Then we will go to truss, and after that, at the final section, we will solve the determinacy of frames. Okay. So if we look at the screen, we will see that there is a simply supported beam here and the point load is acting at the middle or some point on the beam. Okay, so we have to calculate how much unknown reaction we have. Okay, so at first if we look here, there is unknown reaction here, and we already know that at hinge support there is a horizontal reaction also, and at the roller support there is only a vertical reaction. So there are three unknown reactions. Okay, so the value of R will be 3 and the value of E will be 3. So the value of DOI will be R minus E is equal to 0. As we know that if the value of DOI is equal to 0, then the structure is determinate structure, determinate and stable. Okay, the structure is stable and determinate. So if we look at the second problem, we will see that there are two hinge support here and there is an internal hinge also. So the unknown reaction will be here, and at B support there will two unknown reaction. So the value of R will be 4. If we look at the value, we all know that the value of E is equal to 3, but there is an internal hinge here. What is the function of internal hinge? Whenever we will see an internal hinge on a beam, we will consider the moment at that point will be 0. So we are getting a equilibrium equation where the summation of moment will be 0. So we are adding 1 here in E, as we are getting an extra equilibrium equation. So what will be the value of DOI? It will be 0 and it will be determinate and stable structure. Okay. Okay. If we look at the third beam, there is a fixed support at the A point and a hinge support at the B point. So what will happen at A point? There will be a vertical unknown force, there will be a horizontal unknown force, and there will be a moment. At B point, there are two unknown forces, that is vertical and horizontal. So the value of R will be 5 here. There is no internal hinge, so the value of E will be 3. So the DOI value will be 5 minus 3 is equal to 2. As DOI is greater than to 0, the structure is stable but indeterminate. Okay, so what we will write here, indeterminate and stable. Okay, so if we look at the fourth problem, we will see that there is a fixed support acting at A, at B there is a hinge support. So this is quite similar to the third problem. So here the DOI value will be 2 also, R value will be 5 and E value will be 3, and it will be an indeterminate and stable structure. If you look at the last problem, that is fixed support acting at A and two roller support acting the other parts of the beam. So what will be the value? There are 3 unknowns at A: horizontal, vertical and moment. There will be a one unknown support at the middle of the beam, and there will be another unknown support at B point. So the value of R will be 5, value of E will be 3, and DOI value will be 2, which will be the indeterminate and stable structure. Okay, so if we look at the other problems, we can see that there are two fixed support here. It is a fixed beam. So there are in total 6 unknown support here. The value of E will be 3. So DOI value, degree of indeterminacy value, will be R minus E is equal to 6 minus 3, 3, and it is indeterminate and stable, obviously. Okay. So if we look at this problem, we can see that there are two internal hinges here and there are a total of 2 fixed support. So the value of R will be 6. The value of E will be 3 plus 2 and the value will be 5. So DOI value will be 1. So it is also an indeterminate and stable structure. But there is a difference between these two structures. If we say that how much the degree of indeterminacy in the structure, then we can say that this is 1 degree of indeterminacy, 1 degree of indeterminacy, and this is 3 degree of indeterminacy. Okay, this is how we will differentiate the beams. Okay, at the third problem we will see that there is a fixed support, so there are three unknown reaction acting here. There is a hinge support, there are two unknown reaction, there is a roller support, there is one unknown reaction. So the value of R will be 6, the value of E will be 3, so we will get 3 degree of indeterminacy here. And if we look at the last problem, there is a roller support which generally gives a unknown reaction, that is vertical reaction. At hinge there are two reaction, that is vertical and horizontal reaction. At the B point there is a there is a roller support, so it will give a vertical reaction here. So the value of R will be 4 and the value of E will be 3, so the degree of indeterminacy will be 1 degree. So this is how we will solve the beam. We will just look at the support, we will consider the number of unknown reaction here, and then we will consider if there is an internal hinge or something that is giving equilibrium equation, extra equilibrium equation. After that we will just get the difference of this R and E, and we will write down the value of DOI. If the DOI is 1, then it is 1 degree of indeterminacy. If the DOI is 5, then it is 5 degree of indeterminacy. If the DOI is 0, then it is just determinate structure. There is no determinacy. Okay, indeterminacy, sorry. So this is how we will solve the beam. Now we are looking at the degree of indeterminacy of trusses, and we need to understand, we need to remember one formula whenever we are calculating the truss here, that is M plus R minus 2J. This is the formula. What is M here? M is number of bar. Okay, R is number of unknown reaction, and J is number of joint. So if we look at this truss here, we need to calculate the value of M, number of bar here, 1, 2, 3, 4, 5. The value of M will be 5. Unknown reaction R will be 1, 2, 1, 2. That will be 4. And the value of joint will be 1, 2, 3, 4. 4. So what will be the value of DOI? M plus R minus 2J. So M is 5 plus R is 4 minus 2 into 4. So the value will be 5 plus 4 is equal to 9. 4 into 2 is equal to 8. The value will be 1. So we can say that the truss has 1 degree of indeterminacy. Okay, indeterminacy. So this is how we will calculate the truss. If we look at the second problem, let's find out the value of bar 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So the value is 24 and this is 25. Okay, so the value, so the number of bar will be 25. And if we look at the R, there are in total 3 reactions here, 2 verticals, 1 horizontal. We already know that the value of J will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 40. So the value of DOI will be 25 plus 3 minus 2 into 14. That is 28 minus 28 is equal to 0. So we can say that it is a determinate truss. Okay, determinate truss. Okay, if we look at the last problem, we can see that the number of members will be the number of bars will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the number of bar will be, I think it is 14. Okay. 14. So what will be the value of R here? That is 3, 1, 2, and 3. Okay, what will be the value of J here? Let's calculate this. 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. Okay, it will be 8. This will not be considered as a joint here, as the bars are one over another. Okay, so this will be not considered as a joint. So what will be the DOI value? It will be 14 plus 3, 17 minus 2 into 8, that is 16. So the value will be 1, and the degree of indeterminacy will be 1. Okay, it will be 1 degree of indeterminacy. So if you look at this problem, there are three unknown reaction here, that is R is equal to 3. If we look at the number of bar, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So the number of bar will be 12, and the number of joint will be 1, 2, 3, 4, 5, 6, 7. There are 7 joints here, so the number of joints will be 7. And what will be the value of degree of indeterminacy? That is 12 plus 3, that is 15, minus 2 into 7, that is 14. So what will be the value? The value will be 1 degree of indeterminacy. Okay, if we look here, yes, the value is 1 degree of indeterminacy. Okay, now if we look at this problem, the number of bar will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the number of bar will be 18. The number of unknown reaction will be 1, 2, 3. 3. And the number of joint will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So the degree of indeterminacy will be 18 plus 3 minus 2 into 10. That means 21 minus, sorry, it will be 10. 21 minus 20, that will be 1. So the degree of indeterminacy is 1 degree here. Okay. So now we will talk about the degree of indeterminacy of frame. So we need to remember a formula whenever we are trying to find the indeterminacy of the frames. So the formula is degree of indeterminacy will be 3m plus r minus 3j plus e. So we all know that what is m, what is r, and what is j. That is number of bar, number of unknown reaction, and the number of joints. And e is spatial equation. What is spatial equation? Whenever we are getting another equation beside the number of 3 equilibrium equation, then we will consider the value of E will be 1. Okay, so there is an internal hinge here, so we will consider the value of E will be 1. Okay, so the number of bar will be, for the first problem, 1, 2, 3, 4, 5, 6. 6. Number of unknown reaction will be 1, 2 vertical and 1 horizontal, that is 3. And number of joints will be 1, 2, 3, 4, 5, and 6, and 7. So the number of J will be 7 and E will be 1. So the degree of indeterminacy will be 3 into 6 plus 3 minus 3 into 7 plus 1. That will be 21 minus 22. Okay, so the structure is determinate, but it is an unstable structure, and we will get the stability of the structure if we consider a hinge support here. Okay, so this is unstable and determinate structure. So if we look at this part, this math, so we will see that there are a total of 1, 2, 3, 4, 5, 6, 7. 7 number of bars. The joint will be 1, 2, 3, 4, 5, 6, 7. There are 7 joints there, and the number of unknown reaction will be 6. Why 6? Because there are two fixed support. One fixed support gives 3 number of unknown reactions. Okay, so the value of E will be 0. So the degree of indeterminacy will be 3 into 7 plus 6 minus 3 into 7. It will be 6 degree of indeterminacy. If we look at this problem, we will see that there are 1 2 3 4 5 number of bars. The value will be 5. The number of bar will be 4, as there are two hinge support here. So the value of joint will be 1 2 3 4 5 6. There are 6 joints there. The value of E will be 2. So degree of indeterminacy will be 3 into 5 plus R is equal to 4 minus 3 into J is equal to 6 minus 2. So the value will be 15 plus 4 is equal to 19 minus 18 minus 2 is equal to 20. So this is also a determinate structure. Okay, so what will be the value of degree of indeterminacy here? The total number of bar will be 1 2 3 4 5 6. The value of M will be 6. The value of J will be 1 2 3 4 5 6 6. So the number of unknown reaction is 6. E is equal to 0. DOI will be 3 into 6 plus 6 minus 3 into 6 is equal to 6 degree of indeterminacy. And if we look at the last problem of our frame, that will be 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So the number of bar will be 17, and the number of R will be 6, 9, as there are 3 fixed support here. The number of J will be 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So the number of J will be 15. So the degree of indeterminacy will be 3 into 17 plus 9 minus 3 into 15. Okay, so there will be a value here. So this is how we will solve the degree of indeterminacy of the frame. Okay, so we have come to the very last end of our video. We have calculated the degree of indeterminacy of the beams, truss and frames. We have also considered whenever it is acting as a determinate structure and whenever it is acting as indeterminate structure. So we will use this method. We will use the degree of indeterminacy in our very later part of the video, whenever we are calculating the moment, whenever we are trying to solve the analyze the beam using the stiffness method or moment distribution method. We will consider this degree of indeterminacy there. So thank you everyone. If you have any confusion about the video, please try to reach me. I will try to solve you. I will try to help you in solving that kind of video, that kind of problem. So thank you everyone. See you in the next video.